So let's look at what are the given information here in this question. So what's given? So spread. So what's given is the velocity at 90 kilometers per hour. We have the duration for the break, which is 20 seconds. So these are breaks, so we know that acceleration is going to be negative, and it comes to rest. So that gives us an idea that this is the initial velocity, the 90 kilometers an hour, and the final velocity is going to be 0. Now, before I put the units, look at this. So we want the acceleration in meters per second squared. We have the time in seconds, and we have the velocity in kilometers per hour. So what we need to do is we need to convert the kilometers per hour to meters per second, so we can actually solve it. This is probably the easiest way to do it. It's not the only way. So the kilometers per hour, to convert using unit analysis, we want to convert the kilometers on top to meters and get rid of kilometers. So kilometers go on top, bottom, meters on top, and there are 1,000 meters per 1 kilometer. So that gets rid of kilometers. We end up with meters on top. So that's meters per hour, not useful. So instead of hours, we want to have seconds at the bottom. So at the bottom, you're going to put seconds. At the top, you're going to put hour. There are 3,600 seconds per hour. How do you get that? 60 minutes equal 1 hour, and 60 seconds equal 1 minute. Instead of doing two calculations, 60 at the bottom and then another 60, it's just easier to just use 3,600 seconds per hour. I'm not going to ask you where you got that from. But anyway, and this is something that I do expect you to know how to do. It's not something that I would probably provide on assessments. So now the units match up. When you multiply this in the calculator, you're going to get 25 meters per second. Okay, so now let's look at what we have. So we have initial velocity, we have final velocity, we have time, we're looking for acceleration. So we can use the first equation in the kinematic set here, the 4 equations that we looked at in class. And I'm gonna rearrange it in front of you because I know some people had issues rearranging these equations on the skill check that we did. So you have VF equals VI plus AT, and we want to have it in units in terms of A. So what we're going to do is we're going to subtract the VI first from both sides. So VI and VI cancel. On the other side, we're going to have VF minus VI, and that equals A times T. Now, we just want T by A by itself, so we divide both sides by T. And we have A equals VF minus VI over T. If you have it on the other side, it doesn't matter. I just prefer always to have my variable that I'm looking for on the left side. And remember that T is the total time or the delta T essentially, because if you say something took 20 seconds, that means the difference between the beginning at the time, the initial time, and the final time is 20 seconds. So it's kind of like saying the difference is 2 meters between two locations or positions. So anyway, now let's plug in the numbers that we have in here into this formula, rearrange formula, and we have A is equal to VF is 0, sorry, minus 25 divided by the time is 20, and when you put that into the equation, you're going to end up with 1.25, and that's going to be negative meters per second squared. Now, the answer here shows negative 1.3 meters per second squared. That is actually a mistake. Unfortunately, again, with these worksheets, depends on who created them. They used the wrong rounding off method. So we are using the proper big boy, big girl way of doing it, which is 1.2. Since the 2 is an even number, we're going to stay, we're not going to go up 1 meters per second squared. So that's our acceleration. So let's look at another question here. The other question here asks to find the average acceleration for the first 3 seconds for both objects A and B. So the first 3 seconds, that means we're going to go object A, right here, so object B, and object A is going to be right there. Okay, so the first 3 seconds, so you can do 2 points, so point 1 and point 2. That's for A. For B, point 2 is going to be in the bottom there, and point 1 is going to be 0.15. So let's start with object A. So that's going to be the slope, or the difference between the rise over the run, whatever you want to call it. A, the acceleration is the slope of the V velocity versus time graph. So P1, I'm going to rewrite them, and please do so, because I wouldn't be able to understand what's going on. So you do need to communicate your work, and to do that you need to write the points so I know what you're doing, especially with these graphs when the print is usually very small. So P1 is 0, 0, and P2 is 3 and 15. So now if you're looking for the acceleration, that's going to be V2 minus V1 over T2 minus T1. If you remember from math class, is delta Y over delta X. So that will be V2, remember, I'm not going to write it at every single time, but just to show you where this is coming from. So V2 is, V is on the y-axis, so that's pretty much like the y ordinate, and the x ordinate is the t, so that's the coordinates. So this is pretty much your x, and this is your y. So that's pretty much delta x, or the change in y over the change in x, the rise over the run, which gives you the slope. So we put these numbers in, so 15 minus 0 divided by 3 minus 0, which is 5 meters per second squared, and that is positive. You can add that positive in there, or you can leave it, that's fine. I would prefer that you do write it, but I'm not going to penalize you for it. So one significant figure in this case is good enough, because you're dividing 2 by 1. Technically, actually, that's not 1, that's 3.0. So you're actually, it should be 5.0. Yeah, that's the proper way for this question. So let's do the B motion. It's messed up. So for B, we have P1 and P2, so that's point 1 and point 2. Point 1 is 0, 15. Point 2 is 3, and I'm going to go with 12. So when you do your acceleration, you're going to have, again, I want to see all these points, so especially the step here when you put the numbers in, because that's where a lot of people make mistakes usually. So we're gonna go with 12 minus 15 over 3 minus 0, which would be negative 3 over 3, or just negative 1. And that is all that there is for the, even if you have 0.0 here, it will still be one significant figure, since the top is only one significant figure. So negative 1 meters per second squared, which is not surprising because you can see the slope right here is negative. Okay, one last question with instantaneous acceleration from graphs, velocity time graphs. So let's look at 4.5 seconds. So at 4.5 and we're going to look at 4.5 for A. So 4.5 for B. So at t equals 4.5 for B, we are going to look at the slope of this line right here. So let's try it neater than that. So if you're looking at the slope right here, that is all one slope. So at this point, pretty much from point 0, from time 0 to time 5, the slope is the same, which we calculated previously, and it was negative 1. So based on the calculation from before, so from t equals 0 to t equals 5 seconds, the slope or the acceleration is the same. Acceleration for B in this interval 0 to 5 is equal to negative 1 meters per second squared as calculated before. Okay, so let's look at the other problem here for A. So again, you can do the easy thing here and just draw a line that passes through this point. What is this line? It is running along the horizontal line. So you can just simplify, make your life easier. So I'm gonna say for B, for A. For A, acceleration is 0, since the curve or the graph is linear with slope equal 0 because it is a horizontal line. Okay, just make your life easier. You don't need to complicate things. So now let's look at a more complicated problem where you have 7 is right there, so 7 is right here, and so at point 7 right here, and at point 7 is going to be right there. Okay, so at point 7, let's look at B first. So B at t equal 7 seconds. So here we're gonna look at the slope. So you can look at any 2 points along this line right there. So this is the line. So any 2 points along this line. So I will use point 1 and point 2 here. So point 1, I'm gonna pick point 1 was 5 and 10. 0.2 is 8 seconds and 0 meters per second. So the acceleration is going to be 0 minus 10 over 8 minus 5, which is negative 10 divided by 3, or just negative 3. You can say 0.3 or 3. I'm not going to be too picky here, but meters per second squared. This graph here is not very good with significant figures, so I'm just going to leave it negative 3 or negative 3.3. For the other problem that we have now, so here you have a curve. If you have a curve, you do need to draw a tangent line first that passes through that point, okay? And then, so for point A, so find the slope of the tangent line, and the tangent line has to cross at the point where t equals 7, okay? So use any 2 points along this line. So I'm going to use point 2 here, and point 1 we can use it, it doesn't matter really, wherever you want. So I'm just going to use this point right there, P1. So P1, so we have P1 is going to be 7, and I would have to approximate this number here to be 22. And P2 is going to be 8 seconds and 30 meters per second. So when you do the acceleration here, that's going to be your 30 minus 22 divided by 8 minus 7, and we're going to end up with 8 on top, 1 at the bottom, so we have 8 meters per second squared, and it is positive, which again is not surprising here. As you see here, we have a positive line. Okay, that's everything.